Here we are going to talk about how to obtain values from the property table when you have a superheated vapor phase. Alright, so superheated vapor phase exists in this region of the PV or TV diagram. Yeah, so when you have the bell, this is a saturated vapor line. Whatever to its right is superheated vapor. So as long as you enter this region, then you have superheated vapor. Okay. And in this region, temperature and pressure are independent properties. Okay, compare to the saturated phase, where when you have a certain T, the P is always P set. Okay, and when you have a certain pressure, the temperature is always T set. You can just look at table A4 and A5. You immediately get the other property when you have one property. Okay, but in the superheated vapor, temperature and pressure are independent. When you have a pressure, it does not mean that the temperature is a certain value. You have to know both. Okay, you have to know both in order to determine the other things. So for example, you can pause this video to open the table A6. Okay, choose one page in table A6. You'll notice that it is further divided into smaller tables. Okay, table A6. So for example, you have small tables for a certain value of pressure. For example, this one. This small table is only for pressure 0.1 MPa. And then you have a list of temperatures. Okay, then it stops here, and underneath you might have another table for another pressure and then a list of temperature values. So you have to know both. Okay, you have to know two things here in order to find a third property. Okay, that is for superheated vapor. So let's discuss some important characteristics of superheated vapor. Okay, right, here's an important tip in order to know which diagram to draw. Okay, I am sure that sometime in the future you'll ask me this question, which graph to draw. So generally, as a rule, if you know the pressure, we draw the TV diagram. Okay, the reason for this is you can easily label this line as your known pressure value. Okay, constant pressure at this pressure. Okay, and of course the opposite is true. If you know the temperature, we draw PV diagram, and therefore this line will be the T, the constant T line. Alright, so let's look at this one by one. Superheated vapor generally has lower pressure than saturated vapor. So P will be lower than P set when you have a certain temperature. So let's see, we have temperature, so we go to PV diagram. This is the temperature and this is P set. Okay, boiling point, remember? Boiling pressure at this temperature. And for superheated vapor, the P will be lower than P set. So this is P set, anything lower will be superheated vapor. If you want to check, you can create a line. You'll see that it crosses in this region. This region, of course, is the superheated vapor region. Okay. Now, it also has higher temperatures generally than the T set value at any given pressure. So this is the TV diagram. This is a constant pressure that you already know. This is the T set, and the superheated vapor will have a temperature higher than T set. So it will then cross in the superheated vapor region. Okay, compare it to saturated vapor, which is here. Superheated vapor is higher in temperature. Okay, now for specific volume, it will be more than Vg. So let's see, Vf is here. Okay, not important now. Vg is here. This is the volume of the saturated vapor. So superheated vapor will have higher volume. For example, here we confirmed just now that this is a superheated vapor. This is where the volume will fall. Okay, and of course this is more than Vg. Okay, you can do the same comparison in the PV diagram as well. Okay, this will be more than Vg. Right, the other properties will apply just the same. Superheated vapor will have higher internal energy. Superheated vapor will have higher enthalpy. Okay, generally all these three properties are higher. So let's do one example. Determine the internal energy, specific volume, and enthalpy of water at 200 kPa and 300 degrees if the water is in superheated vapor condition. Okay, we know that this is superheated vapor because it's stated here. So therefore, we go to table A6. Yeah, and in table A6, remember first you have to know the pressure. So pressure given is 200 kPa. And table A6 is given in MPa. So therefore, divide by 1000, it's 0.2 MPa. Okay, 0.2 MPa. And then you go down the first column and you find temperature 300 degrees. Okay, you can pause this video, find it first, and proceed. Okay, you will see that the internal energy U is this value, 2808.8 kilojoules per kilogram. The volume or specific volume is such, and H is or enthalpy is this value. Okay. Question B. Based on A, if the water condition is not stated, how would you determine the state point? Okay, what it means is here it's stated that it's superheated vapor. So what if you don't have this? What if the question only gives you these two information, but it does not tell you that it's superheated? Okay, which is normally the case. In the future, you will not be told that it's superheated. So what you do here is, based on the given information, which is 200 kPa and 300 degrees, you can draw the PV or the TV diagram to prove that this is in fact superheated. Okay, I'm going to show how to do that here. I choose to draw the TV diagram. Okay, you can draw either one because you have both information. So based on the diagram, as you draw the diagram, you label the information given from A4 or A5. What information I'm talking about here is, you draw the TV diagram, this line will be 200 kPa because this is the pressure you know. Okay, now be careful not to label this line as 300 degrees because it's not necessarily 300 degrees. What this is actually T set at 200 kPa. Okay, so you have to go to A5, find 200 kPa, what is the T set, and label it here. Alright, and then you'll find that it's much less than 300 degrees. Okay, so next, number 3, prove the state where the lines cross. Okay, so we know this is not 300. 300 is all the way above, and it will cross this 200 kPa line in this region. Okay, and therefore, it's proven that this is a superheated vapor. And finally, number 4, you can obtain any necessary information that you have to once you have confirmed that it is superheated vapor. Okay, another example. Determine the temperature of water at state of P equals 0.5 MPa and H is 2855.8 kilojoules per kg if water exists in superheated vapor. So in this question, you are told that it's superheated, okay, and then you have the pressure, but instead of having the temperature, you have another information, which is enthalpy. So it's actually just the same. You go to table A6, you find 0.5 MPa, and instead of referring to the temperature column, you go to the enthalpy column, which is H. Go down the enthalpy column, you'll find this value. Okay, and this value corresponds to the same row as 200 degrees. Okay, so this is also another way the table can be used. All right, and based on my explanation at the beginning of this video, you know that the H here, of course, will be higher than Hg. So if you were to go to table A5, you go to this pressure, you'll find that Hg is less than the given enthalpy. Okay, this is just a general rule. So we're going to end this video here, and the next video will be about compressed liquid.